Water can be easily reduced to dihydrogen by highly electropositive metal. For example, means if you want to separate out hydrogen from H2O molecule, then what we have to do? We have to take a electropositive element, a more electropositive element, to reduce hydrogen to H2. So what's going on here? The oxidation number is changing from -1. Sorry, what is the oxidation number of hydrogen here? Can you tell me? In the water molecule H2O, what will be the oxidation number of hydrogen here? Who can tell me? But you can speak instead of sending in chat box. Okay. So the from +1 to 0, because H2 is 0. So what is going on? Reduction is going on. Means oxidation number is changing from +1 to 0. Clear? So it can reduce to dihydrogen by highly electropositive ion, or highly electropositive ion is Na, sodium. So it is a great source of dihydrogen. Water is oxidized to O2 during photosynthesis. 6C, I think you all are familiar with this equation. 6CO2 plus 12H2O gives C6H12O6 plus 6H2O plus 6O2. So the oxygen that releases means like that releases by the plants, which we actually intake for inhalation, that is released from the water molecule. So with fluorine also it oxidizes to O2. So if you react water molecule with electronegative element, then oxidation takes place. So when you react water molecule with the electropositive element, hydrogen will evolve out, and when you take a electronegative element instead of electropositive, oxygen molecule will evolve out. Okay, so water is the great source of hydrogen and oxygen. Clear? Let's just talk about the hydrolysis property. So what does it mean? Hydrolysis. Hydrolysis means when something break. Lysis means टूटना. Hydro means water. Water के अंदर dissolve होने के बाद जब कोई चीज टूट जाती है, तो that process is known as hydrolysis. For just like electrolysis, when something break in presence of electrons or electricity, that process is known as electrolysis. And hydrolysis is when something break into, means, or you can say something dissociate when you mix it in water. So due to high dielectric constant, it has a very strong hydrating tendency. It dissolves many ionic compounds. However, certain covalent and some ionic compounds are hydrolyzed in water. So water is considered to be as a great solvent because of its dielectric constant. Dielectric constant means it has the property to produce dipole. It has the property to break the ionic and covalent compound and create poles. One positive and second one is negative ion. Okay, so let's just take example. P4O10, when mixed with water molecule, it gives H3PO4. SiCl4, when mixed with water, it gives SiO2 plus HCl. When your nitrogen mixed with the water molecule, you will get ammonia and OH negative ion. So it can dissolve covalent compound as well as ionic compound. So this is considered to be as the universal dipolar solvent, because all those compounds, all ionic and covalent compound, can mix easily with this water. Okay, so it can dissolve each and everything. So let's just talk about the hydrolysis of sucrose. What is sucrose? Sugar. C12H22O11. And we know this thing that from in 10th class we have studied your sugar, when break down, it forms two products, that is fructose and glucose. So when you mix sugar or sucrose in water molecule, when you hydrolyze it, what happens? You will get glucose and fructose. Clear? So this is actually how hydrolysis happen. For example, if you dissolve NaCl in water, what happened with NaCl in water? When you dissolve a salt, common salt in water, you will get Na positive ion and Cl negative ion. So that is also a hydrolysis process. Okay. Let's just learn about hydrate formation. Okay. For from aqueous solution, many salt can be crystallized as hydrated salt, such as association of water is of different type. So hydrates, when your hydrogen combine with some compound, some specific compounds, so they will form hydrate, crystallized hydrate salt. Crystallized hydrate salt means a crystal type salt. है ना? जैसे NaCl. NaCl is a crystalline solid, right? Forms crystals. Sugar is a crystalline solid. So same way, there are different types of hydrates. First one is coordinated water. Second one is interstitial water. Third one is hydrogen bonded water. Now how you can differentiate this thing? When your hydrogen form coordinate bond with the molecule, it form coordinated means when it just combine as like coordinate compound. Interstitial means when water means get entered and take a place in the interstitial side of the crystalline solid. मतलब क्या है, हमारे बेटा जब सॉलिड्स बनते हैं ना, आपने देखा होगा, आप किसी डब्बे में किसी लड्डू भरो, लड्डू हमारे घर में होंगे, लेट मी जस्ट गिव यू एग्जांपल, हमारे पास लड्डू हैं, हमने उसको किसी डब्बे में भरा, तो क्या वो उस पूरे डब्बे के वॉल्यूम को कंप्लीटली ऑक्यूपाई करेगा? नहीं करेगा. There will be some space that actually remains between the particles. आपके लड्डू के बीच में जो स्पेस रह जाएगा, उस प्लेस, उस जगह को हम क्या बोलते हैं? इंटरस्टिशियल साइट, है ना? द वेकेंट स्पेस बिटवीन दी अटैच्ड मॉलिक्यूल्स, आपके जो भी मॉलिक्यूल्स में अटैच हो रहे हैं उनके बीच में जो खाली जगह रहती है, दैट इज इंटरस्टिशियल. So sometimes what happen? They take the place at the interstitial sites. So at that time, that is known as interstitial water. Third one is the hydrogen means this water molecule make hydrogen bonding with the compound and exists in that form. So here are some examples of coordinated water, of interstitial water, or hydrogenated water. Clear? So let's just start with the heavy water. What is heavy water? है ना? Sometimes people used to say that यहाँ का पानी बहुत hard है ना? Hardness. तो हम उस hardness को किस तरीके से remove करेंगे? How we can remove that hardness? So we'll understand this thing topic with these things when we'll go down to the chapter. So let's continue with the heavy water. Heavy water. The formula, molecular formula is D2O. D2O. Just like H2O, the heavy water formula is D2O. It is extensively used as moderator in nuclear reactor and in exchange reaction for the study of reaction mechanism. It can be prepared by exhaustive electrolysis of water or as byproduct of some fertilizer industries. So what is the main purpose of this D2O? D2O is used in like as moderator, and moderator means as controller to perform some nuclear reactions, है ना? And how we can get it? We just can prepare it by electrolysis, by exhaustive electrolysis of water, or sometimes we can get it as byproduct. Byproduct means as waste product or extra product when we produce or prepare fertilizers in fertilizer industries. Okay. So what is the physical property? Learn the molecular mass. Molecular mass is 20.0276. So you can summarize this 20.02 gram per mole. Melting point is 276.8 Kelvin. Boiling point is 374.4 Kelvin. So note these things down because they can ask you these things. This molecular mass, melting point, boiling point, because there is a difference in D2O and H2O. So to create that difference, they can ask you. The bottom ice cubes were made with heavy water, which in water they use deuterium hydrogen molecule with the extra neutron, not a regular hydrogen which has no neutron. So if we talk about that how we can form this, like what is the property of this hydrogen? Being H2O is a simple molecule, hydrogen molecule. We do not have any neutron. But when we form D2O, it means why this is called as D2O, because we are taking deuterium, which has neutron in its nucleus. So that is why the name is D2O. We are taking that hydrogen in which we have what? Means like in which we have deuterium, which consists neutrons in them. Okay, let's just talk about the production of hard water, how we can produce it. So there are different types of method which we apply to produce hydrogen, means D2O heavy water. Let me just show you. Uses for the preparation of deuterium compounds, कि भाई किस तरीके से हम how we can prepare some other compounds from the deuterium. So when you react it with CaCO2 with D2O, you will get C2D2 and CaOD2. When you react SO3 with D2, you will get D2SO4. When you react AlCl, Al4C3 plus this D2O, you will get CD4 and AlOD4. But technically, this is a hydrogen. Technically, this is a hydrogen, but a different isotope of hydrogen, which is known as what? Which is known as the deuterium, because of the presence of neutron inside it. Clear? So let's just talk about the uses of hydrogen. So hydrogen being have high calorific value, so it's a highly inflammable, so it's used for means as fuel. Hydrogen is most abundant and simplest element in the universe. Hydrogen has no elasticity, it does not have any elasticity. Hydrogen is flammable, that is why it is used as fuel. Remember this thing, to burn something, है ना, वी रिक्वायर हाइड्रोजन. कोई चीज जलती है वो हाइड्रोजन की वजह से जलती है, और रिक्वायरमेंट बेसिक क्या है? ऑक्सीजन. तो हाइड्रोजन एंड ऑक्सीजन, these are two different gases. Hydrogen is highly inflammable, which is used as fuel. ऑक्सीजन is that gas which favors burning. बिना ऑक्सीजन के आपकी कोई चीज जल नहीं सकती, ठीक है, which favors burning, but together when they combine and form water, they are used as fire extinguisher. Okay, so hydrogen is an energy carrier, that is it's a cleaner fuel, or its high calorific value is high. That is why hydrogen is used as fuel in spacecrafts and spaceships, in your rockets, satellites, you know? Hydrogen can be cooled and stored as liquid, as we all know that hydrogen and oxygen, both the gases can be stored, liquefy easily and can be stored in liquid form. Atomic hydrogen is highly reactive. The nascent hydrogen is very reactive from a hydrogen. What do you mean by nascent? I have used this word many times while teaching you. Nascent means navjat, newly formed. Newly formed means when we prepare hydrogen from anything. Single hydrogen atom is known as nascent hydrogen, and same with nascent oxygen. And when hydrogen is in H2 form, dimolecular form, at that time that is known as hydrogen gas. There is a difference. When you see hydrogen in bracket, when you see a hydrogen molecule, single hydrogen atom एक bracket के अंदर हो, parentheses के अंदर बंद हो, big bracket के अंदर, so that is known as nascent hydrogen. और अगर if that is written as H2, so H2 is molecule, hydrogen gas molecule. Liquid and compressed hydrogen storage, technically feasible in use as prototype vehicle. Focus is on meeting packaging and mass and cost target. Both methods fall below energy density goals. Unique vehicles, architectures and design could be enable efficient packing and extend curve. So if we talk about the compressing and like liquid nitrogen, so it can be used in vehicles, in like so many things where we require a large amount of energy, and means what it is considered to be as near as good fuel, है ना? Cleaner fuel, ideal fuel we can use word here, because what is ideal fuel? Whose calorific value is high and which produce less pollution. So being a gas, flammable gas and high energy source gas, hydrogen is used as fuel. It's considered to be as ideal fuel. Solid state solid state storage, fundamental discovery and institute necessary idea storage resources and environment. So sometimes you can just lower down the temperature and increase the pressure, and at that time you can solidify it also and store it for a long time. So your oxygen, hydrogen, both the gases can easily liquefy and solidify and used and can be stored and transported easily from one place to another. Hard water. What is hard water? Sometimes we used to see कि when we drink water ना we feel like कि भाई something is going inside our mouth or throat, तो वो बहुत hard feel देता है. कभी पानी में बहुत नमक वाला टेस्ट आता है ना. Sometimes when we use soap, तो कितना भी आप सोप लगा लो उसमें foam produce नहीं होगा. That is actually the hard water. And when you just put some small amount of salt and you will feel a large amount of foam in that, it means that quality of water is soft. Okay. So hot water and like it's just precipitate with soap. When you mix hard water with the soap, it get precipitated. Okay. So that type of water which do not let the production of foam with the water and it get precipitate instead of forming foam. So that is known as the hard water. And this hardness of water can be removed by so many process. Sometimes like doctor used to suggest that when you are sick, then take boiled water. हमें boiled water पीने की सलाह देते हैं डॉक्टर्स. ठीक है. Why? Because so that boiling reduce the hardness of water. कभी जैसे आप सर्दियों में आएंगे तो कुछ के घर पे ना वो यूज होती हैं रॉड, पानी गर्म करने के लिए भी यूज रॉड है ना. तो कुछ टाइम बाद जब हम उसे नया लेकर आते हैं तो वो स्टील की होती है. जब उसमें कंटिन्यूअसली हम पानी गर्म करते रहेंगे रॉड लगाकर, तो रॉड के ऊपर एक व्हाइट कलर की लेयर जमा हो जाती है. That is the impurities which makes the water hard. Clear? So there are different methods through which we can remove the hardness of water. So these are the hardness is of two types: temporary hardness or permanent hardness. Temporary hardness can be removed by simple processes like boiling, adding some simple things, chlorination. But permanent hardness need proper chemical processes. Okay. So temporary hardness is due to the presence of magnesium and calcium hydrogen carbonate. It can be removed by boiling. So firstly, it can be removed by boiling. When you start boiling, what happens? Your magnesium hydrogen carbonate ion will break down or compounds will break down and form magnesium hydroxide as well as the carbon dioxide. And when calcium hydrogen carbonate compounds are there, you will get calcium carbonate जो white color की layer deposit हो जाती है, that is calcium carbonate, water and CO2. So if you want to see that your water is hard or soft, so take it in a bowl, start boiling it. जब आप उसे boil करके ठंडा होने के लिए रखेंगे ना, तो आपको एक बहुत पतली सी layer ऊपर नजर आएगी. So whenever you boil your water, keep it for some time for like to reduce the temperature, and then filter it through a cotton sheet, cotton cloth, so that वो impurities उसमें से पार ना हो पाए. Filter papers use करते हैं, filter cloths आते हैं. ठीक है. तो ये चीज तो आप खुद अपना घर में देख सकते हो कि that how much the water is hard in your area. Clear? So first method is boiling. Second one is Clark method. In this method, calculated amount of lime is added to hard water. It precipitates the calcium carbonate and magnesium hydrogen carbonate, which can be filtered off. So if you produce like if you add lime into the water, what is lime? Lime is calcium hydroxide. In 10th class you have studied. Okay? So when you add calcium hydroxide with your calcium hydrogen carbonate and magnesium hydrogen carbonate, so it's just dissociate or break the compound and form calcium carbonate as well as with water. And in with magnesium hydrogen carbonate, you will get calcium carbonate plus magnesium means OH2 negative hydroxide and H2O. Clear? So these are the way to remove the टेम्पररी हार्डनेस. और घर में हम नॉर्मल फिल्टर्स यूज करते हैं. व्हाट वी यूज इन फिल्टर्स, आपके जो आरओ सर्विसिंग के लिए आते हैं वो कहते हैं हमें सेल चेंज करना पड़ेगा. वी यूज टू चेंज द फिल्टर. सो दैट फिल्टर, व्हाट इज द बेसिक नीड ऑफ दीज सेल्स जो उसके अंदर सेल लगे हुए होते हैं. फर्स्ट they just precipitate the calcium carbonate, separate out from that. Okay. Second, they enrich your water with the minerals. और minerals के में क्या होता है, they used to add some salt, some pulses and so many things which are rich in different minerals. Okay, वो सब ऐड किया जाता है. Then you will get a pure water from RO. So that is why your RO water tastes different from your household water, because it is purified, no hardness is there in that water. Accompanied with that, the water is mixed with so many rich ions, mineral ions. Okay, let's just talk about the permanent hardness. So it is due to the presence of soluble salts of magnesium and calcium oxide in the form of chloride and sulfate. In the temporary hardness, it means your water is mixed with calcium and magnesium hydroxides, means hydrogen carbonates. But if we talk about the permanent, so this is due to the presence of magnesium calcium in the form of chlorides and sulfates. Permanent hardness can be removed by boiling. And first, a part of boiling, you have to add so many things to remove it. First is treatment with washing soda. Washing soda is sodium carbonate. You have learned this thing in 10th class. So when you react washing soda with the means calcium and magnesium chloride and sulfate, what happened? They will form a insoluble carbonate. So MgCl2 react with Na2CO3. It gives MgCO3, NaCl. When MgSO4 means sulfate react with Na2CO3, it gives MCO3 plus Na2SO4. So that is how we can remove the permanent hardness. Apart of this, there are another method, Kelogen method and ion exchange method. Kelogen method means sodium hexametaphosphate, commercially is called Kelogen, is added to hard water and that react and remove the permanent hardness. Ion exchange method, in this method we just call zeolite or permutate process, you can say. So hydrate sodium aluminium silicate is a zeolite, and sodium aluminium silicate can be written as NaZ, which when these are added to hard water, exchange of ion takes place. Exchange of ion means same, this means this ion exchange will takes place, and what will lead to this means, for example, you will get your फाइनल प्रोडक्ट. दिस इज नोन एज डिस्प्लेसमेंट रिएक्शन ऑल्सो ना, कि ये आयन यहाँ जाएगा, उसको वहां से हटा देगा और अपनी जगह ले लेगा. दिस इज समथिंग लाइक दैट. So this is actually happened in ion exchange method. And ion you can take magnesium, calcium, whatever you want to take compound, and whatever you have in your lab. Okay. Second is when you have like zeolite MZ2, and when you just exert it with NaCl, mix NaCl with that, so you will ion exchange, same ionization ion exchange will take place, and you will get NaZn plus MCl2. Your metal will come out, and this M can be your magnesium, calcium, whatever impurities there in the water. Okay. Synthetic resin come method. But याद रखना, whenever your RO person come, so before installation of installing the RO, they just check the TDS of your water. That TDS tells the hardness or the you can say softness of the water. That is that water is permanent hard or temporary hard. ठीक है, उस पानी का TDS decide करने के बाद they will change your cell. If the TDS is good, so there is no need to take means install RO, or no need to take heavy filter. Synthetic resin method. This method is more efficient than zeolite process. Cation exchange resins contains a large organic molecules with groups and present in insoluble water. So same this ion exchange method is also there. In this we just take resin to regenerate the compound and separate the salt, NaCl compounds or salt from this the water. So for example, if we have RNA and if we add M2 positive, M2 positive means it can be Ca2 positive and Mg2 positive. So you will get your compound and you can remove the hardness of water. Okay.